All right, we're back. I'm still on page 260 because I want to go back to the calculator and I just want to show you that you could actually solve this problem on your calculator if you were so inclined. So I'm going to go back to a calculator page and just show you. So to save a little bit of time, I defined this ahead of time. I just did f of x colon equals and then make sure you put multiplication here. It actually won't be a problem, but you should just get used to putting that. If you have a variable times something, you should always start with multiplication because you should put multiplication in between. Otherwise, you get this invalid implied multiplication. It thinks you're defining a weird new function. Like, you just want to watch out for that. So I've defined this, and I just want to point out that you can actually solve things. Excuse me. All right, so menu 3, 7, and then A and B are the variables because I want to solve for those. And what I'm going to do is I'm just going to use the limit template and say the limit as x approaches 0 from the left of f of x should be equal to the limit as x approaches 0 from the right of f of x. That's one equation we need to solve. And also, you could probably copy and paste this. It's a little harder for some reason for me to do that. So to copy and paste, you hold shift, arrow through it, control C, put it where you want to be, control V, and that'll do it. Equals the limit as x approaches 2 from the right of f of x. And then I'm gonna press enter, and you can see that it does it for us. The one thing that it does that's a little weird is it gets a common denominator for b, which we did not do, but that's still pi over 2 minus 2, which is what we got. So I just wanted you to know that your calculator can do a lot of stuff, and you are like in charge of figuring out what you can and can't do. You need to put in the effort, press the buttons, make sure you can do it. All right, let's start page 2, whatever. I don't know if you can hear the bird that's outside, but it is intensely screaming. All right. So if a function is continuous, which means the limit exists, the function exists, the limit equals the value of the function. If a function is continuous at a point, you would never bother talking about left continuous or right continuous. So continuity, continuous at a point, it trumps everything else. Like, once you say something's continuous, you never think like, is it left continuous? Is it right continuous? No, it's continuous. Don't even worry about it. But if a function is not continuous at a point, sometimes an interesting thing can happen. And we've already talked about this. When we were doing them visually, I mentioned it a couple of times. We have these ideas of left continuous and right continuous. So left continuous means that the limit as x approaches c from the left, as you're walking from left to right, you get the value you expect. The limit as x approaches c from the left equals f of c. And then the limit as x approaches c from the right, like, doesn't equal that. That's kind of the supposition here. So this would have a graph maybe that looks something like this, right? So as you approach from the left, going this way, you get what you expect. The person approaching from the right doesn't get what they expect. And that's what it means for a function to be left continuous. So you'd only ever talk about this if the function is not continuous. If it's continuous, you're wasting your time with this. Right continuous is the exact opposite. A person walking from the right to the left gets what they expect. So a graph for that could actually look like, I mean, let's be more exciting, right? Could look like this, right? So the person who's walking from the right to the left, they're walking from the right toward the left. And usually, I guess I usually blindfold them, right? So that it's a little more exciting. They're not really sure what exactly they're gonna get. But in this case, the person walking from the right toward the left, going this way, is definitely gonna get what they expect. The person walking from the left to the right, they're actually going to negative infinity, so that's not great for them, probably, potentially. So they're not a big deal, but they exist, left continuity, right continuity. It's good to be familiar with concepts. So I want you to know that these things exist so that, when it comes up, you're not like, what is anyone talking about? So let's see if we can do this. Discuss the continuity of this function. All right, I'm gonna start off with a graph because I think it's like the easiest way to deal with this function. So what's important? 3 and 5 are important. So 3 and 5. And then when x is equal to 3, the first branch it only applies when x is less than 3. But if it did apply at 3, I would have gotten 3 out of it. So I'm going to say 3 and just put an open circle. And then draw basically y equals x. Between 3 and 5, including 3 and 5, the function is 5. So do this, just go straight across. And then when x is greater than 5, the function is y equals x again. So it's going to go like this. So this is our function. So this is kind of interesting. I see 2 points that I'd like to address. I'd like to address what's happening at 3, and I'd like to address what's happening at 5. So I'm going to say the limit as x approaches 3 of f of x does not exist. Therefore, f of x is not continuous. Can't be continuous at x equals 3. But since there is more going on, let's say, but since the limit as x approaches 3 from the right of f of x is equal to f of 3, right? So look at your graph and you'll see that that's true. As we approach from the right, so as I do this, I get the value I'm expecting. The limit as x approaches 3 from the right of f of x is f of 3. It's equal to f of 3. I'm going to say f of x is right continuous at x equals 3. So not continuous, but it is right continuous. It could be not continuous and not be right or left continuous, just like nothing going on there. But in this case, it's not continuous because the limit doesn't exist. It is right continuous because the limit from the right equals the value of the function. So it's just more information. And then the other point that I want to address is x equals 5 because it's a breaking point and you always want to address those. So let's do that. So the limit as x approaches 5 of f of x equals f of 5. Therefore, f of x is continuous at x equals 5. All right, so we dealt with it. Should I? Yeah, I'm going to do the next one. All right. So describe the continuity. So describing the continuity really just means find the discontinuities. It's kind of weird. So I'm going to say like continuous for all reals except whatever, and then say y. So you can kind of tell. Let's create a graph. I think a graph will be helpful. So it's x squared when x is less than 2, and then 3x minus 1 when x is greater than or equal to 2. So x squared when x is less than 2. So at 2, if I could get to 2, I would get 4. So I'm going to put a point, I'm going to put a tick mark there, and then an open circle. And then just go like this. Okay. And then the other definition is 3x minus 1 when x is greater than or equal to 2. So when I get to 2, I'll get 6 minus 1 is 5. And then 3x is your slope, so like really steep. Okay, 3 is a really steep slope you will find in life, especially if you're counting by ones. Like a slope of 10 might as well be vertical. Imagine that, like a staircase where to go like 1 foot forward, you have to go 10 feet up. Like, come on. It's, for all practical purposes, basically infinite. All right, so once you have the graph, you can see what's going on. You can see what's going on from the function definition too. I think it's good to create graphs because it makes you think graphically, and the more you think in graphs, the easier life will be going forward for the next like 2 years at least. So try to create graphs, always be thinking about them. All right, let's see. The limit as x approaches 2 from the left of f of x is 4. The limit as x approaches 2 from the right of f of x is 5. So therefore, the limit as x approaches 2 of f of x does not exist. Could we have gotten away with just saying does not exist to begin with and skipping the left and right? Maybe, but like you never know. Therefore, double therefore, that's a weird sentence. But therefore, f of x is not continuous at, am I at the edge? X equals 2. Not continuous at x equals 2. But, look at our graph. But the limit as x approaches 2 from the right of f of x equals f of 2, which maybe I should say the value equals 5. Therefore, f of x is right continuous. So right continuous. Oh man, that's a bad continuous right there. At x equals 2. So it is right continuous. The question, however, was describe the continuity. So, I mean, I kind of did. So I'm going to say f of x is continuous for x is an element of the reals, comma, x is not equal to 2. 2 is the only place where we have a problem. This is like the actual answer to the question, by the way. All the other stuff is just like getting there. And then we get interested, right? Like the limit doesn't exist, but what does that mean? Like you can't just walk around saying like, I know a secret about this limit. No, it's like, what is the limit? Don't just tell me it doesn't exist. Like what's going on? Is it a jump discontinuity? Is it right continuous? Is it left continuous? Like what is happening? All right. So the next problem we're gonna do involves taxes, but it involves a different tax table, which is already out of date, but I didn't feel like updating it. This is an even more out of date tax table. And we're going to look at these things. So just like look at this, look at the values. There's nothing really important in this one because the next problem is about a different thing, but it's going to involve something like this. We're going to find the values of A, B, and C and see like where they come from and how this whole thing works, and then we'll graph it. Potentially, it might take a long time. I don't know. Anyway, I'm going to wrap this up here, and I will be back in the next video to do more of this. Hope you're finding this helpful.